problem. We have x equals 1 over the square root of t plus 1. I strongly suggest you start with x and get t by itself, because then you're taking that variable and plugging it in for y. It's already in y equals 4. So it is less work, because otherwise, if you solve the y one, you have to plug it in for x, and then you have to resolve to get y by itself. So like you're solving twice, and that is a little bit of extra work. So if you look at the x variable, what's one thing you could do to try and solve for t? Because that's what we're trying to eliminate. That's the parameter. David?
You square them right away?
You could square them right away, yes. So square them right away. That's one option you could do. So if you square them right away, you're squaring the left side, you're squaring the right side. So that would leave us with x squared, I'm going to place it over 1, and 1 over, we'll just make this a t plus 1. So squaring the top is just a 1. Squaring the bottom means the square root of 1 plus t squared just becomes 1, or t plus 1. All right, so our goal is to get t by itself. So we had got the square root out of the problem. What else would we do to try and get t by itself? Aaron?
The inverse of the 1 over t plus 1.
Okay, so I think maybe. So we want to get that out of the denominator. So we could multiply both sides by it. So those cancel and give us a 1. On this side, we have t plus 1 times x squared. David?
Is that just the same as like cross multiplying?
It is the same as cross multiplying. That's exactly what we just did. So if we cross multiplied, 1 times 1 is 1, x squared times t plus 1. Same exact thing as cross multiplying. Remember, your goal is to get the t by itself. So what else do we do, Anna?
I divided by the x squared.
Yeah, divide by x squared to take it to the other side. And then Anna, finally,
You subtract the 1.
subtract the 1 to take it to the other side. So we would have 1 over x squared minus 1. So to get rid of the square root, at some point you have to square both sides. You didn't have to do it first. You could have kind of done that somewhere throughout the problem. But if you do it first, you get rid of the square root. And then you have to get rid of the fraction, so you can cross multiply, multiply by the reciprocal, multiply by whatever's in the denominator. They're all doing the same thing. Just depends on how you're thinking about it. And then the goal is to get t by itself. So I didn't distribute x squared through the problem. I got rid of it by dividing it to the other side so that we could just subtract the 1 then to the other side. Questions? So t is now by itself. In my y equals equation, we're going to replace the t so that we have rectangular form, which is a y and an x back into the same equation. So up here, t on the top is 1 over x squared minus 1. On the bottom, we have a t, which is 1 over x squared minus 1, and then there's a plus 1. So my t is this 1 over x squared minus 1, 1 over x squared minus 1. But the denominator had that plus 1 as well. So Marie, what happens in the denominator?
The negative 1 and the positive 1 cancel.
Yeah, those guys cancel out, which is kind of nice. A negative 1 and a positive 1 cancel. We still have 1 over x squared. And the top still has 1 over x squared, but it has the minus 1 with it.
Could you also have it as x negative 2, like x to the negative 2 power?
We usually keep exponents positive form. So a negative exponent is considered unsimplified.
Right, because I looked at like the negative form.
Right. How would you simplify that? Right?
Considering to get the fraction out of the bottom, you have to multiply by the reciprocal. Could you first on the top make the negative 1 x squared over x squared?
Yeah, so you're subtracting 1, trying to get a common denominator. So negative 1 becomes x squared over x squared. So that means we have a 1 minus x squared over x squared. On the bottom, we still have 1 over x squared. Now Marie said you would multiply by the reciprocal of the denominator. What else happens? What do you notice about the top and the bottom? What do they both have?
X squared.
An x squared. Where is that x squared at, Zach?
It's on the denominator.
Of both of them. So what happens with that x squared, Zach?
They cancel.
They cancel. So the x squared in the denominator, the x squared in the denominator cancel. If they're both in the denominator, they're going to cancel out because you're really multiplying by the reciprocal, as Marie said. So our leftover equation is just the 1 minus x squared. Did anybody get that? Nice, a couple of you. There's one extra little piece that we have to add. Even though there's no restriction to x in the answer, you still have to look above to see if there's a restriction for x. So, looking back at our work, going back to the original x, you've got to look at that original x. It's not y, because y is the dependent variable. It depends on what we restrict x, so you don't have to worry about the y. But going back to the original problem, what would the restriction on x be? So think to yourself, like, what can't x be? Right?
X can't be negative.
It can't be negative because you have a positive 1 divided by a square root. A square root is always a positive answer. So it can't be negative. There's something else it also cannot be.
It can't be 0
It can't be 0. Why can't it be 0?
because you can't divide a number by 0. It's just, you can't like divide
Yeah.
like 5 into 0 pieces.
So anytime you have a 1 on top, that 1 on top, no matter what you place on the bottom, is never going to be 0 because you can't divide by 0. So 1 divided by any number is something that's always going to be not a 0 value. The other reason it can't be 0 is because in the denominator of all of my work, I have x squared. X squared cannot be 0. So there's two reasons it can't be 0, because there's an x in the denominator, but also because this fraction will never have a value of 0. If I have a 1 on top of anything, a 2 on top of anything, if it's a fraction with a number on top and just a number by itself, that fraction can never be 0. So our restriction would be that x, if it cannot be 0 and it cannot be negative, then my only other option would be that it has to be positive. It's got to be greater than 0. So again, it can't be 0 because x is in the denominator and the 1 is on top of that original fraction defining x. It cannot be negative because there's a square root. When you take the square root of a number and it's already in the problem, it's only a positive answer. So that's why it has to be a positive answer and it has to be bigger than 0. Questions? So the last part of the problem wanted you to graph. Oh, the directions are above. So we're going to make a quick little sketch here. And then it said to show the orientation. The orientation is the direction that the graph moves based off of time. That's part of the graph. Every parametric equation has to have orientation. Otherwise, the graph isn't correct. Because no longer are we always graphing from left to right, but we're graphing with respect to how time increases. So Ethan, what kind of graph would 1 minus x squared create? And where does that parabola move?
Left one
So it is pointing down, I agree with that.
Up.
It goes up 1. So it moves up 1 because of the 1 in front. The negative makes it point down. So on my y-axis, we're moving up 1. But x has to be greater than 0. How on a graph do you show something has to be greater than it, or that it can't equal it?
Dash line.
A dash line, or we put a circle, yeah, an open dot at that point. So it's not allowed to be 0. So I can't put a closed circle there, I can put an open one. And then Ethan said it faces down. So we have a parabola that's facing down, and we only have the half of the parabola that's greater than 0, so the half that's on the right. So we're moving over 1. 1 squared is 1, but I'm going down because it's a negative. over 2. 2 squared is 4. But again, we're moving down because it's negative. So we have half of a parabola going down because it's a negative x, right? The last thing you have to do is indicate the orientation of the curve. The only way you can do that is to figure out what happens as time increases. So that means that you got to look at time and think of how time is affecting the equation. I'm going to erase the part up here at the top. So this is not a simple little sweet problem. It's actually a pretty involved problem algebraically. And then we graphed. And now we have to go back and still think about time. So if you pick two numbers for time, we're making like a tiny little T-chart. Easiest numbers to choose are always 0 and 1. 0 makes sense to start at time of 0, move forward to the next second of 1. When you plug a 0 in here, what is your x value if you plug a 0 in? Ethan? 1. Ethan, what's the x or the y value if we plug a 0 in for t? 0. So my first point is 1, 0. So I'm just going to kind of look at my graph. Right here is 1, 0. So now I need to know what direction are we moving from 1, 0 to get the orientation of the curve. And that's where I get a second point, because then I can kind of see the direction that we move. So if we plug in a positive 1 for t, I end up with 1 over the square root of 2, which is really the square root of 2 over 2. And then when I plug in a 1 for t, I end up with 1 and 1, so that would be a 1/2. So that point is the square root of 2 over 2 and 1/2. We need to know where that point is. So you all have a calculator on your desk. Don't write the decimal down, but understand where that decimal is. Recognize where that is. So we have the square root of 2 divided by 2, or 1 divided by the square root of 2. You're going to get the same answer. What is that value? 0.707. And that, when we did trig, we used that number, 0.707. So my 0.707 and 1/2. 0.707 is less than 1, up to 1/2. That would be my second value. So which direction is the graph moving? Yeah, it's moving to the left. So because my first point was on the x-axis, my second point is to the left of it. That means the graph, the orientation, is moving left. So even though time is increasing, and time increases the positive direction, it actually is forcing the graph to move in the opposite direction. Questions?
How do you know it's moving in the opposite direction?
Because I found two values of time. My first value for the time was at the point 1, 0. My second value of time was before that. So right here's 1, 0. Here's my second value. So comparing those two, as time increases, I'm actually moving to the left. Question?
You compared the x values?
I chose two t values.
T values.
Yeah, and then just compared my 2 points after I plotted them.
Okay.
So I picked a t value of 0 for time. Increasing time means my next value would be 1, so that time is increasing. But then comparing those 2 points, here is the first point when time is 0, so that's point 1. Here's point 2 when time is 1 second. So that second point is to the left. So since it moved left, my graph is moving left. So if I pick the negative amount, my negative point would be down here. It would be lower, underneath the x-axis. Other questions? So if you look at number 3, this is going to kind of help a little bit with number 23. For number 3, we have x equals 3 times the cosine of theta, y equals 4 times the cosine of theta. And then it says theta is supposed to go from 0 to 2 pi. Why would theta go from 0 to 2 pi? What is theta? An angle. when we graph angles,
A circle only goes to,
say it again, Kate.
a circle only goes to.
A circle goes to 2 pi. It starts at 0, it goes to 2 pi. So when you're finding theta, it represents t. It's still our parameter, but you're not using seconds because it's not time, it's an angle. So when you're making your t-chart, you can't use -2, -1, 0, 1, 2. Because it's an angle, it's not time. So if it's an angle, you have to use angles. If it's time, you have to use seconds. And that's just like having centimeters versus inches. Like depending on what you're using, you have to kind of restrict your values to those special numbers. So we're going to use that time in a minute, or those angles in a minute, but the direction said for us to eliminate the parameter. Now the parameter is technically theta, but what's theta attached to? So in the equation for x, what's theta attached to? Cosine. I cannot separate them. I can't divide out cosine. It doesn't work that way. So let's keep those two together and get rid of the 3. Katie, how would you get rid of the 3?
Just divide.
Yeah, just divide it. So right now we have the cosine of theta would be x divided by 3. Those two are attached. The only way I can get rid of them is by using the inverse function. We're not going to use the inverse function. Just keep them attached. So keep the angle and the function with the angle. So Katie, if I want to do the same thing with the sine, sine would be equal to y over 4. All right, so trig wasn't that long ago. We were done with trig on March 8th, which was really only a little over a month ago. There is something that we have learned and used a lot that relates sine and cosine together. Right?
I was just gonna say, could you take the arc cosine and the arc sine?
We could, but that it's not really going to help us because now then I have these inverse things. Jared, what did we use that relates sine and cosine together?
Sine squared, cosine squared add together equals 1.
Yeah, sine squared plus cosine squared, when you add them together, equals 1. That's that wonderful Pythagorean identity. And that's an equation. It is an equation. It has an equal sign that we can use maybe to help us eliminate the parameter. So if you have a sine squared in the problem, Jared, what do you think you're going to replace sine squared with?
Y over 4 squared.
Yeah, y over 4 squared. So an equation can be replaced with whatever piece of the equation it's equivalent to. Stupid TV. So replace sine squared with its term. Replace cosine squared with the cosine term. See if you can simplify that equation. There we go. So cosine is x over 3 squared. Jared, what would y over 4 squared become?
Y squared over 16.
And x over 3 squared is?
X squared over 9.
What's that rectangular form? 4.
Nope, ellipse.
An ellipse.
That's ellipse.
Okay, you gave me 3.
It's an ellipse.
It's ellipse with plus.
Ellipse because it's plus?
And then it's
What direction does it go? Vertical or horizontal? Vertical because bigger number. What's the center?
0.
0, 0. So parametric equations, when you use sine and cosine, create an ellipse in a rectangular form. So we're going to do a basic graph. We're not going to do a big fancy graph like we did with cons. Make yourself a little graph. Just said the center was 0, 0. We also said it was vertical. A squared is 16. Vertically, that means I move up 4, put a point, move down 4, place another point. That's my vertices. A connects the vertices. B goes the other way. Well, b squared is 9, so b is 3. Left, right. Yes, I know there should be foci in here, but we're not graphing an ellipse. We're graphing a parametric set of equations. So connect your dots.
Looks like a circle.
Kind of does look like a circle.
Well, yours is
David.
better than mine, so I thought for ellipses it was horizontal. Those first.
That would be the hyperbola, the positive term for a hyperbola. Which number is bigger on the bottom? And what is it attached with, x or y? The y. So the hyperbola, it's whatever is positive. An ellipse is where is the bigger denominator. So wherever the bigger denominator is, that tells you the direction that it goes. Okay, so the last thing we have to do, these problems are a little longer. You still have to know the direction that it moves. So that means you need to pick two values. It cannot be time because we're talking about an angle. So instead of picking a time value, pick an angle value. What angle would be a good angle to pick? 0. What would be another easy angle to pick? Anything after 0. Doesn't matter. Pi, sure. You could have picked pi over 2 if you prefer pi over 2. But you need another angle that's going around the unit circle past 0 in that positive counterclockwise direction. All right, so using that wonderful brain of yours, when you plug in 0, you're taking 3 times the cosine of 0. What is the cosine of 0? Katie? 1. The cosine of 0 is 1. So 3 times 1 gives me an x value of 3. The other one says 4 times the sine of 0. Katie, what's the sine of 0?
0.
Yeah. So then I have a point at 3, 0. That's my first point. So this is where my graph would be starting if I started at the angle of 0 on the unit circle. Now you guys also said to use pi. So again, I'm picking pi, plugging it in, 3 times the cosine of pi. Pi's on the other side of the unit circle. What's the cosine of pi? -1. So that becomes -3, and then again it's going to be 0. Here's my second point. So my graph starts here. It moves up and goes to the second point. And then it would go down and move to the next point.
How do you know it doesn't go down and to the left?
Really, we should probably find an angle in between to know for sure. But if we found the pi over 2 angle, it would take us up to the top. Questions? So take a peek at your number 23 in your homework. Yeah, so looking at number 23, Yeah.
Same direction.
Yeah.
That was when we moved
No, unfortunately, I don't know what happened to my 23. I just had it. I didn't leave my homework anywhere, right? Nobody has my homework.
Did your kids eat
Maybe. I had it. I don't know what happened to it. That's a bummer. It's gotta be somewhere, because I know I didn't throw it away. So look at your 23. When you're picking the angle values and making your t-chart, use 0, pi over 2, pi, 3 pi over 2, 2 pi. Use those values. Set them equal to cosine and sine, and then you're going to plug it into that Pythagorean identity. So that's sine squared plus cosine squared equals 1. Number 35 on your homework. The goal was for you to use your calculator. Graph it in the calculator and see what happens to it. There were 4 things, and the direction said to compare. What's the difference between those 4 equations? All 4 of them made a line. It's just it was parts of the line that you were looking at and the direction that the line was graphed. So if you didn't do that one correctly, go back and just plug them in the calculator and make sure that you kind of see the graph moving up or the graph moving down or the graph moving left to right versus right to left. Some of the graph, the whole thing is drawn, other times only a little piece of the graph is drawn. So kind of go back and just look. Number 35 is more asking you, like, what is the difference between these four equations? They all make lines, but what's the difference between all of the lines? Questions? So I'd like you to look at the, it's page 7 in your packet, but for some reason the page 7 didn't appear, the number at the bottom. So there are 5 problems on here that are part of your homework. There's no work that you are like actually needing to do on here. It's more of a calculator activity. Make sure your calculator is in degree mode. There's not a final answer, right? So the equation is one of the final answers. The graph and the orientation is the other part of your. So like here's your rectangular equation, the graph. Those would be your final. Correct. You should find the point up here. You should find hypertension. So that we know that this is you would plug in hypertension.
Oh, that is 1 to 5. I think it might be a 6 through 10.
So like down here, the angle pi over 2. 3 pi over 2. And then put theta under 10. So like when you're making your T chart, so if we made a T chart up here instead of T, you would have 0 pi over 2. That's fine. 3 pi over 2. So looking at the calculator activity, the goal of this activity is for you to kind of look at the T step, which we did yesterday a little bit, and see how the T step changes the graph. The first 5 equations, which you're asked to do tonight, 1 through 5, are the same exact equations. You have the same x and y values that you're plugging in for the min and the max, the same t min and max, it's just the t step changes. So you're asked to plug it in your calculator, draw yourself a little picture. It says the coefficient relates to the radius, so the coefficient of 8 in front of the sine, 8 in front of the cosine. It's the same coefficient, so you're going to get a radius of 8 that talks about the circle. So that's going to kind of correlate with your radius. When you get to number 3 on the next page, it asks you to compare 1, 2, and 3 and write a little statement. What's happening with the graph? And then you're going to graph number 4 and then write a little statement after it. And then you'll be graphing number 5. After 5, the equations change, which is why I asked you just to do 1 through 5 tonight, because the rest of it, the equations are different. If you want to, feel free to graph all of them. They get really cool as you kind of work through them. They actually are really different graphs. So that's part of your homework. The other part of your homework that I want to kind of talk about with you is numbers 37 through 39 and 41 through 43, because the two kind of go together as a pair. It's crooked, but you can still read it. So 37 says eliminate the parameter to obtain the standard form of the rectangular equation. And it's telling you in 37 that it's going to be a line. 38 is going to be the equation of a circle. 39 is going to be the equation of an ellipse. So you're going to eliminate the parameter, which means in my x or y equation, you're going to get t by itself, and then take that, just like we did for the 2 problems, and plug them in to get an equation with a y and an x. Your equation for number 37 should look like the equation of a line. Once you eliminate the parameter for number 38, it should be the equation of a circle, x minus h squared plus y minus k squared equals r squared. So the goal is to take those 3 parametric equations, pull them together to get our rectangular form that we've been working with. And then 41 asks you to go back to those parametric equations. Can you see 41? Nope. So 41, you're going back to the parametric equations that are written in the book, not the equation you create, because you're creating a rectangular form. But going back to the equation, the parametric equation that's in the book for number 37, you're plugging in actual points. And your goal then is to get a set of parametric equations that passes through that point. So for number 37, it gives you the equation of a line in x and y. You plug in the x's, you plug in the y's, you get an actual equation for that set of points. Number 42 is a circle, so again, you're plugging in that information into the parametric equations that are given. Questions? Jared?
There was a bar graph we did yesterday. I just had a question on it. I'm assuming, like, I know you did a bar graph in the first one, right there, and now I was assuming like this, you guys have a written restriction here, because I know the one that we did earlier had like a value that should be undefined.
So,
Brandon.
like, these guys, what you're
Well, I went through it yesterday.
Yeah.
And so they, the Y min or the Y max.
Oh, right, you're right.
I mean, it still looked weird, but I guess it definitely starts on the and then what it's
all you have to do is
because
change
I'm
the
just always
T-sub
asking because I thought
and change the
I guess
T-sub
it's
to
kind of
create
dumb of me too, that based on the equation it was restricted already. I guess I see here, these are all real numbers here, but.
Aaron, did you have a question?
Yes. Tomorrow I won't be here.
Okay,
Is there anything you gotta pass out?
no, it's all written on the assignment sheet.
Are you taking notes tomorrow?
Yes.
You giving us homework over break?
I am. Your free day was Monday. You weren't here, so you had a free day.
It's not a free day, my